So let's look at the free body diagram. Again, let's consider the cylinder by itself. We have the radius r. We have a tension from the rope going downward. And we have big mg as its weight. And we know it's rotating counterclockwise. For the block, what we have is tension going up and the weight little mg going down. Notice that there's only motion in the y direction for the block. So if we do the sum of the forces in the y equals mass times acceleration, we're going to get, in the y direction that is, we're going to get the weight, let's do this, the tension is going up, so that's a positive, minus the weight going down, which is a negative. And since the block is accelerating downward, that would be a minus little m. Let's call it a sub y for now. And so this is for the block. If we do or consider the cylinder, we can do the sum of the torques around some point of rotation is going to be I alpha, and we only have one rotation due to the tension, so that's going to give us RT because they're perpendicular to each other. That's going to equal, and it's counterclockwise, so it's positive I alpha. So if we look up the moment of inertia for the disk around its center, again, we will find out that it's 1/2 big M r squared. That's alpha. And now we can say that from this equation, T equals 1/2 M capital M R alpha, because the R's will cancel, and R alpha by itself is the tangential acceleration, so that's AY again, so the tension is 1/2 big mass AY. So now we have T, which is 1/2 big M AY minus little m G equals minus little m AY. So we can say that 1/2 big M AY plus little m AY equals mg. If we separate what we're looking for, we want the acceleration, so let's factor that out. We get 1/2 m plus little m equals little m g. And so we can say that AY equals, I'm going to rewrite this as 0.5 big M. So this is mg over 0.5 big M plus little m. Right? Which means if we plug this back into the tension equals 1/2 big M times A, which is little mg over 1/2 big M plus little m. And And I don't see this simplifying much more, so we can just leave it. We can maybe divide the m out and say this is mg over, or 1/2 times mg over 0.5 plus little m over big M. I don't know if that's simpler or not than this, but we have found the tension and the acceleration.